So let us see some applications of this inductive effect, how this inductive effect is useful in the discussion of the properties of the different compounds. So the first property, let us see the acidity of the carboxylic acids. Even the phenols also you can explain. Acidity of the phenols also you can explain. Specifically, it is not the reason of the acidity of carboxylic acid, but the how the acidity is going on changing we explain. So therefore, the acidity of the carboxylic acid actually explained by the resonance theory. It's originally, let us say, it is a formic acid. If formic acid donates a H plus, okay, leaves the H plus, and what is formed is called formate anion. This formate anion formation has one right way, that is, if this proton is lost, the anion formed has a beautiful resonance. So that's why this formation is a Reddy process. This phenomenon is called what? Resonance. We take it as a second phenomenon. Don't get worried. But here you have to understand this phenomena little. So therefore, I'll explain. What is resonance means? Whenever a molecule or ion, when it can get two structures or more than one structure, the charge is moving, or pi bonds are moving. So the reactivity of the compound decreases, stability increases. The phenomenon is called resonance here. So this anion has two structures, this side minus and that side. So the minus is moving, the pi bond is also moving, thereby its stability increases, rate of reaction decreases. So this molecule has a stability. That's why the process of donation of the proton is explained as easy. This process is easy. So therefore, it is acid. So any compound, if you take first of all, it must have a hydrogen to lose the proton, but all the compound which have hydrogen may not lose. After losing, what is the consequence? Anion formed, if it has a stability, it will lose, otherwise no. So in this case, we have a resonance stability. Therefore, the process of losing the proton is easy, or it is favorable to this molecule. The removal of the proton is nothing but the acidity definition. Any compound that gives a proton is called acid. So this acid is donating the proton, therefore it is acid. Now the application of the inductive effect is, if this compound has a chlorine here, what is the influence on this acidity? That is the influencing fact. Because originally this bond has got polarity this side or that side, leave it. But because the chlorine pulls here, the carbon also try to pull. The oxygen originally pull, but because of the chlorine, the pulling property increases. Therefore, removal of the H plus has become more easy. So therefore, the reaction now it is much more easily the anion formation is taking place. So the H plus is removed. The anion formed is called now chloroformate. Chloroformate ion has now two stabilities. One is the anion gets stabilized, therefore resonance stability is there. And the anion is the problem, but the Cl is taking some electron density, therefore the negative charge is decreased, therefore it gets stability. Or it is pulling, therefore the proton is given out, therefore forming anion fastly. Either way you can explain. In the chloroformic acid, the chlorine pulls, therefore the proton coming will become easy. Or the anion formed, the anion negative charge is problem. All charged species charges are problems. Neutral molecule is more stable. That is the general theory. O minus is a problem. The minus charge is partly the Cl is taking out. So the effect of the positive charge decreasing. Therefore, it is stabilized. So the chloroformate ion is more stable than the formate ion. So that is, the chlorine makes the two more readily donates. Therefore, it is stronger acid. Why it is stronger acid means two ways you can explain. One is, in the acid itself, chlorine has a minus I effect. Therefore, proton coming will become easy. That's why it's stronger. Or the anion formed, that is consequence of the donation of proton, anion formed has more stability than the formate ion. That's why readily the chloroformate is formed, that is nothing but the proton donation will become easy. So, finally what we say is chlorine containing formic acid is stronger acid than the acid. Why the formic acid is acidic? Because of the resonance, that is nothing to do with minus I or the inductive effect here. Here the chloroformic acid is stronger. The comparison is that we are explaining through this inductive effect. Chloroformic acid is stronger acid than the formic acid. Explain the reason means this chlorine, I will say inductive effect, that too withdrawing, isn't it? So, the inductive effect is classified into two types. Withdrawing effect is called minus I effect, donating effect is called plus I effect. So, in this case the chlorine withdraws, therefore, the minus I effect of the chlorine, therefore, the chlorine is strong acid when compared with the normal acid. This is acid, if I say this I call strong acid. Similarly, a group which is showing a methyl group reversely, a methyl group is a plus I group, isn't it? Why the methyl is plus? Means which are showing the minus I means all electronegativity elements containing groups are termed to be the minus I. Arbitrarily, no minus, that is electronegativity containing alkyl groups, all alkyl groups will take it grant as a plus I group. So, when minus I group increases, plus I group decreases, therefore, this compound is a weaker acid it is. So, arrange these three means first strong acid, then normal acid, then the weak acid. So, in general you can have any minus I group containing carboxylic acids are stronger, any plus I group like methyl, ethyl, propyl are the weaker acids. So, huge number of examples you can take, like for example, within the halogens we have a fluorine containing acetic acid and a chlorine containing acetic acid. Both are acetic acid, but fluorine is a more minus I, therefore, this is stronger than the chlorine. Number of groups also you can take. 2 chlorines containing acetic acid is a stronger one than the 1 chlorine containing acetic acid, right. The position of the halogen also. There is a propanoic acid attached to the chlorine on the second carbon is stronger one than a chlorine attached to the third carbon. 2-chloropropanoic acid is stronger than 3-chloro. As I said, the chlorine is moving away. So, therefore, it is distance is increased. So, the net result on the pulling of the, that is electron density or stabilizing the anion decreases, therefore, it is said to be decreased. Similarly, the acetic acid is a stronger one when compared with the propanoic acid. That means one extra plus I group is there, more the plus I groups the acidity is decreased, isn't it? We have a propanoic acid with one methyl on the this case which is stronger than the propanoic acid has a methyl closer one. This is propanoic acid, this is also propanoic acid. You can say it is 3-methyl propanoic acid, it is a 2-methyl or N-propanoic acid, isopropanoic acid, isobutyric, N-butyric acid, isobutyric acid. N is stronger because methyl is a donating group, should be away from the system, then it will become the strong acid. Donating group closer, it will become weak acid, isn't it? Minus I group should be closer to increase the acidity, plus I group should be away from the system, so that the acidity is more. So, therefore, N-butyric acid or butyric, common name it is, N-butyric acid is stronger than isobutyric acid. The group that is plus I group closer one, it is the acidity is less in fact. So, similar the case in the case of phenols also you can say. Phenol also has got a chance of donating the proton after the removal of the proton, the phenoxide get resonance stability. So the fundamental question, why phenol is acidic? Phenol itself is an acid, right? But if you have a chlorine, the acidity is increased. Why phenol is acid means phenoxide has a resonance stability, therefore phenol is acid. It's an application of resonance in fact. But the chlorophenol is stronger than the a chlorine attached at a third position. This is called what? Orthochlorophenol is stronger than metachloro. Metachloro is stronger than the parachloro. Parachlorophenol, which is stronger than ordinary phenol, and which is stronger than any alkyl group having, like let us say a CH3 group is there. So a methyl group is a donating group, therefore it is weaker. So just based on the inductive effect, all these three are inductive minus I groups, so stronger than phenol. That is a plus I group, weaker than the phenol. Whereas in this one there is no donating or withdrawing, it is taken as a standard. And in this the group which is closer is stronger, little away is weaker, much more little away, therefore it is more weaker. But all chlorophenols are stronger than the phenol. Okay, rightly explained here. The minus I effect increases the acidity, plus I decreases the acidity. So therefore the carboxylic acid's acidity as well as the phenol's acidity can be explained by the inductive effect.